Hello viewers and welcome to my YouTube channel. In today's video, we are going to study about quadratic forms. Let us begin with the definition of quadratic forms. A quadratic form q of x1, x2, xn over r in n variables is an expression of the form summation ij equal to 1 up to n aij times xi times xj, where aij is a real number. It is a linear combination of two variables taken at a time. Let us see an example for n equal to 2 followed by n equal to 3. So if we take for n equal to 2, then q of x1, x2 is going to be sum I comma j equal to 1 up to 2 aij xi xj. And when we put I equal to 1 and j equal to 1, we are going to get a11 x1 into x1. When we put I as 1 and j as 2, we are going to get a12 x1 x2. Reversing the values, we get a21 x2 x1, and lastly we get a22 x2 x2. And this simplifies to a11 x1 square plus a12 plus a21 into x1 x2 plus a22 x2 square. For n equal to 3, we have the quadratic form denoted by q of x1, x2, x3, and this is going to be a11 x1 square plus a22 x2 square plus a33 x3 square plus a12 plus a21 into x1 x2 plus a13 plus a31 into x1 x3, and lastly we will have a23 plus a32 into x2 x3. So these are the quadratic form, the general quadratic form for n equal to 2 and n equal to 3. In general, if suppose say x is equal to x1, x2 up to xn is a vector in Rn, then the quadratic form of x is going to be summation I from 1 to n a I xi square plus summation I not equal to j I j from 1 to n aij plus aji into xi xj. This is the general quadratic form for a variable in Rn. Now how do we apply this quadratic forms to the world of matrices? It is explained by this theorem. So if we have a vector x bar in Rn with coordinates x1, x2 up to xn, and q of x bar is the quadratic form over R in n variables, then we can always find a unique real symmetric matrix such that the quadratic form q of x bar can be expressed as x bar transpose times b times x bar, where x bar is treated as a vector. Now for example, if suppose say we are given a quadratic form, consider the quadratic form q of xy is equal to 4x square plus 6xy plus 8y square. Then we can construct a real symmetric matrix B, which is going to be 2 by 2 since we have two variables, and the entries of this matrix are going to be 2, 3, 3 and 4. Later on I will be telling you the shortcut for this, and also vice versa if we are given a real symmetric matrix. So let's take A is equal to a real symmetric matrix with entries 4, 3, 3 and negative 1. Then for this, the corresponding quadratic form q of x is going to be x transpose ax, where x is the vector xy column vector. So this is going to be xy times the matrix 4, 3, 3, negative 1 times xy. So we'll first multiply the first two matrices. Now since we have a row matrix whose order is 1 by 2 times a matrix whose order is 2 by 2, the resultant matrix will be another row matrix with order 1 by 2, and that matrix is given as 4x plus 3y and 3x minus y times xy. Now we have a row vector multiplied by a column vector, so the result is going to be a 1 by 1 matrix, which is going to be just a single entry. So it is going to be 4x square plus 3xy plus 3xy minus y square. So thus we can see that the quadratic form of x can be written as in the form of a function instead of a matrix. It is going to be 4x square plus 6xy minus y square. Now, if you will compare this example with the earlier example, I just want to tell you how we can go vice versa without going with each and every step. Now, the shorter trick to convert from a quadratic form to a matrix and vice versa. So, if we have a real symmetric matrix A with entries A, H, and B, then the corresponding quadratic form Q of xy is given as ax square plus 2h xy plus by square, and of course the vice versa part holds. So if this is the quadratic form, then a comes as the first member of the principal diagonal, b is the second member of the principal diagonal, whereas 2h is splitted in the non-diagonal entries. So that's it for today's video. I'll be keeping it very short. In the subsequent videos, we are going to see more solved problems from IIT JAM, NET and SET examination based on the topics which we have discussed, that is eigenvalues, eigenvectors and diagonalization. If you have followed this video, then please like the video and also share it with your friends. Do not forget to subscribe my channel and also press the bell icon to get notified about upcoming videos. Thank you so much once again.